Welcome back to the Rule Your Pool podcast, everybody. I know it's been a long time, but we're actually doing this one on video. I have with me, as always, my co-host, well, not always, but a lot lately, Jared Morgan. Jared, it's good to see you.
I'm happy to be here, and I would also say sometimes host. Don't forget that.
That's a self-declared role. It's not really.
Again, I'm declaring it again right now.
Not really the host.
You're welcome.
No, you're not really the host. It is a good-looking microphone, though. But Jared, this is a first time for us. Do you want to introduce him?
Mr. Bill Drakeley from Watershape University, and I would absolutely call him an expert in our field.
Bill, thank you for joining us. Everybody that I asked for many years when I had questions about concrete, they said, you need to call this guy Bill Drakeley. Tell us a little bit about who you are, what's your background, and how did you get to know so much about concrete?
Well, thanks for having me on. I know what I know, and it's from the upbringing I had. So a little history on my background. My grandfather was in World War II, came back and started a septic company. And it went from septic tanks to swimming pools via cast-in-place material. And he started a construction company and did a lot of concrete work just as an Italian son of immigrants who fought and went through the Depression, went through World War II, and then lived the American dream. So my mother's side of the family started in concrete construction early on. And I was working when I was a kid, picking up paper cups on job sites. And my dad worked for the state of Connecticut as an auditor and special revenue. So we had an interesting my dad was a sports guy and he coached, and my mother's family was concrete construction. So we just got stuck with the crews, and whatever crew we ended up with that day, that's what we did. And I was usually with the concrete crews and holding a hose.
How old were you?
When I first held a hose, 12.
So 12 years old. You have been around concrete, specifically Shotcrete, for decades upon decades. In this episode, Bill, we have you on because we are not subject matter experts in concrete. This is episode 80 of the Rule Your Pool podcast. Jared, you ready to get into it?
Let's do it.
Let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Okay, let's start, Bill, with an understanding of what concrete and cement actually are. In just a brief few sentences, what's happening when we put water into cement?
Well, cement, it's a Portland cement. It's type 1 or type 2. You add hydration or water to these particles and they grow calcium silicates, which are little fingers on top of this particle, and it's a grabbing mechanism. So the water and cement make paste, and that paste is the bonding agent that holds the sand and aggregate together in your concrete matrix.
And when you say aggregate, you mean rocks and pebbles and stuff like that?
The strength of any concrete is the aggregate, the sand or the rock. The cement is not strength. All it is a binding mechanism. And it's the best binding mechanism known to mankind.
Interesting. So that kind of ties into the next question about mix ratios, because plaster surfaces tend to be weaker than pebble surfaces, and that's probably because the pebble is the aggregate, which makes it a much stronger surface. Would you agree with that?
I don't know if I would agree with that. Your sand and your finer materials have a compressive value equal to any pebble in your plaster. I would say that your water cement ratios, which is not really governed in a plaster installation by troweling, was vital to durability and compressive value. So let's take concrete. In the old days, we wet up the floor and shoot the floor because it was easier to move around with a come along or a trowel because we had stuff to do that night and we were beat to hell. Let's wet the floor up and leave. Well, we didn't know we were ruining the chemistry of the concrete. We didn't know we were weakening it. We didn't know that if we added more water of convenience, the compressive value, durability, and longevity of that pool floor went down. That was not smart. That was bad. Hell, I did that as a kid. I didn't know any better. I was watching the guy in front of me. And in the plaster scenario, I think it's the same thing. Water of convenience and troweling and adding, you change the chemistry. For example, let's take a microscopic view. You add too much water and your cement particles, they're pushed away from each other microscopically. The water dries or evaporates or leaves. Then you do a compressive value. The mix design with the parts are closer together in a nice intact material unit is a stronger material, compressive value-wise, durability-wise, porosity-wise, than it would be if you added more water. That's why when you add water to concrete trucks when it's hot out and they're sitting there spinning or somebody's not getting the foundation poured, they add water of convenience so it doesn't harden on them. It's weaker.
Okay, so two questions. When you say compressive value, how is that measured?
You take a sample and you squeeze it until it breaks.
Well, I mean, in what unit of measurement?
PSI, pounds per square inch.
The other question is, you said water to cement ratio. What is the optimal water to cement ratio, and what are the tolerances of what is acceptable and not acceptable around it?
Water to cement ratio is the amount of water divided by the cementitious material content of a given sample. And you divide that, you try to get them both in pounds, so you divide the pounds of water by the pounds of cementitious material. That could be Portland cement with pozzolanes, silica fume, fly ash, blast furnace slag, anything with cementitious properties, you get a ratio. Your ratio, when you do that, it's got to be between 0.38 and 0.48, and it's easily done by anybody on the job site with a phone and your calculator. Anything above 0.50, there's too much water in your mix design. Below 0.38, you can't move it, it's too stiff.
So like 0.45 is acceptable. 45% of whatever's in that hopper is water, and the other 55% is cementitious material.
Essentially.
Okay. Now, Jared, did you know any of what Bill just told you? Did you ever know what that ratio was? I never even thought about it.
I mean, honestly, it's never been something that I have personally paid attention to. I've heard it in passing, being at the trade shows and in classes, but it doesn't mean anything to me. I'm just thinking concrete's concrete. I'm looking out at my driveway or my sidewalk, and somebody just poured it down there, troweled it, and we're good to go.
Let's keep it separate now. A water cement ratio is easily measured in the components of a concrete mix design because it's pre-mixed. I don't think there's a measuring technique after the trowel for your water cement ratio unless you do an analysis. We can figure it out when it's in the truck, and that's what we want to know. We want to know that I can pump it, shoot it, and it stands up at this ratio. Your ratio is not determined, I don't think, until you squeeze it on the shell, correct?
That's a question I don't even know how to answer, Bill, to be honest with you. We're not really qualified. We're not the subject matter experts on the actual cement. We know how pool chemistry interacts with cement, but what's going on inside the cement from what started on the truck, that's why you're on this episode. In this one, I want to keep it focused on Shotcrete because the next episode, we're going to dive into plaster finishes, but we will come back to that. But back to PSI. What is the ideal PSI for a pool Shotcrete shell?
Well, according to the American Concrete Institute and the American Shotcrete Association, your minimum compressive value should be 4,000 psi. And that is based off of a durability chart originally put in ACI 318 and carried in ACI 350. We'll have it in ACI 506, the Pool Shotcrete Guide, which I'm the chairman of. But essentially, certain conditions of concrete exposure dictate compressive values. So minimum compressive value of 4,000 in the presence of moisture. Okay, well, when concrete's in the presence of moisture, in order to protect its steel, it needs to be 4,000 psi and have low permeability. In the presence of freeze-thaw, in the presence of lateral pressures, the compressive value, technically from ACI, should be 4,500 psi. And if you take it one step further, if you have brackish water or seawater or salt water, or guess what, chlorine generators, your compressive value is supposed to be 5,000 psi. Now, it's not hard to get to. You have to try hard to get less than 4,000 psi. You really have to try to cheat the process to get down to that level.
On that question, how do they regulate the PSI when they're applying a gunite surface or the shell?
Well, PSI is determined by your chemistry and your amounts. Okay, you can pour a sidewalk that's 6,000 psi out of the back of a truck in a wheelbarrow, and you can shoot a pool at 6,000 psi. So the shotcrete process, the spraying process at a high velocity, which gives you good impact and good encapsulation of your steel. Dry mix shotcrete or wet mix shotcrete, your minimum values are the same and your maximum values will be the same. It's just a means and methods of getting your concrete product onto the steel substrate. Just so that the readership and everybody's watching this, shotcrete, or people call it gunite the old way, it's a verb, it's an action. It's not a product. The product is spraying concrete. A lot of concretes have different internal components, aggregate size, mix ratios, whatever, but you're spraying concrete. You can't pick up a handful of shotcrete or gunite, you're picking up a handful of concrete. At the end of the day, that's it.
It's just how you apply it.
So the ratio of the concrete and the water and the mix itself determines the PSI of what's being applied.
Yeah, as long as who's shooting it doesn't screw it up so bad. I will tell you that shooting concrete is a very, very hard way to make a living. Okay, none of us went to Harvard. It's a hard living, and guys who do this for a living, if they're asked to meet a certain compressive value, means they have to have a certain amount of Portland cement and certain amount of aggregate and certain amount of techniques that will slow down the shot process, and it'll cost them more than what they were used to 20 and 30 years ago. Okay, so you get less than 4,000 PSI, you're cheating the process, but you're saving money. And if you do it for a living, how many tractor trailer loads of Portland cement, which goes through the roof on a yearly basis in terms of cost, will you save if you cut down your ratio from a 3-to-1 or 4-to-1 mix ratio? 1 shovelful of cement and 4 shovelfuls of sand will give you 4,000 PSI if you do everything right. Oh, okay, let's go 1 shovelful of cement to 6 sand, and let's save on the Portland and use the shot product to compact all that crap together, and hopefully the pool stays together. Well, if you have a lateral pressure or hydrostatic pressure or some type of movement, this pool's going to break. Now, do you need 4,000 PSI for a pool to work? Well, no. Liner pools work. Above ground pools work. You just need something to hold the water. But when you get into a concrete situation where you have resistance or pressures or movement or settlement or whatever, the plaster mimics whatever is underneath it, and you do garbage for concrete, it shows through in the plaster.
I have so many questions. First thing, 4,000 is the minimum. I'm going to guess you don't aim for the minimum. Where do you typically try to shoot your pools that you actually build in your business?
Well, we do our own mix design with aggregate ratios, 3/8 down the sand. I get 6,000 PSI after a 28-day wet cure.
Okay, so 6,000. Would you say that's kind of standard with the high-end builders like yourself in the pool industry?
No.
So where do you think they're aiming?
I don't know if they're aiming. I'm hoping they're getting 4,000 PSI. The other part of this equation, Jared and Eric, is we self-perform. I'm a nozzleman. We do everything in-house except for plaster. So we can control and do our product. When you sub your Shotcrete out and you don't know what it takes to build properly, you're at the mercy of the subcontractor. I mean, I don't want to get off on a tangent. We don't have a lot of time. But you don't know what you're doing, and you're building a high-end pool. What do? You go buy waterproofing or damp-proofing agents, and people say, well, Bill, don't you do that? I says, no. Why would I put a waterproofing agent on my pool when it's watertight in its concrete state? Why would I put something between my concrete and my plaster and interrupt that important integral bond? And the answer is, why would you do that? Because you don't know what your subcontractor just put in there for concrete, so you better protect yourself so the plaster doesn't fall off the pool and you don't get sued.
That's what I was going to say. Isn't that almost like an insurance policy for things like that?
It is.
That's how I see it.
But is the bondability and performance of the plaster better on a damp proofer or better against the concrete substrate?
We have no idea, Bill. That's why you're on the Rule Your Pool podcast. Come
Let
on.
me answer my own question. Concrete to plaster is the best bondability in terms of those two products.
Okay. No, understand where we're coming from. We see plaster problems. We don't see Shotcrete shells very often. By the time we're called, the pool's either about to be filled or it's already been full for a while and there's a problem. We see a lot of issues like weepers, efflorescence, calcium nodules, and these are things that moisture's coming through that Shotcrete shell.
Right, you're identifying porosity issues within the shell. You're identifying permeability issues. Listen, plaster guys are the best thing that's ever happened to concrete guys because we screw it up and you try to fix it. Thank you very much from the bottom of my heart for doing that.
I guess you could say the same about water chemistry because for many, many years, Bill, people were recommending hot starts after a really ugly acid wash or a lack of an acid wash and just an ugly, ugly surface. We see it all the time.
Well, let's not pretend they are still recommended.
Yeah.
Well, okay, but it's getting better mainly because we were very vocal about it. But the idea that you just cook this thing with acid to undo the ugliness that was just left behind from the troweling and the lack of good exposure, that's not chemistry's job.
No.
And yet we cover up the sins of whatever that is, if you want to call it that. But I don't want to get too off track because that'll be.
Well, so you asked me about porosity. So not shooting a good mix design, not shooting with the right velocity, using wrong angles with your nozzle, overspray, dust, whatever you're doing to prevent solid encapsulation and solid material, you're leaving voids.
Well, do you think that there needs to be more PSI if you have retaining walls like vanishing edges or raised spas? Because that's where we see efflorescence being pushed through those walls.
On the backside of a bond beam or something where it's an erased planar
Right,
bed.
well,
and
don't
it's
get
coming
confused with 10,000 PSI can crack and have water penetration issues because it cracks in certain areas. There's a big formula here. You have quality steel, quality forming, quality soil science and geotech analysis, quality shotcrete, thickness, compressive value. It's all part of the same equation. Now, I can have 4,000 PSI in a vanishing edge wall and I spray it uniformly where there's no voids and there's no porosity. And what do I mean by this? Well, if I had to test a pool and it had cracks down a certain end and cracked on another end and water leaked, and you would say, well, this pool probably has a low PSI. Well, that's not necessarily true. I can core drill a pool in 50 different spots and get 6,000 PSI. But in the spot that it cracked and it leaks, the compressive value is half of that, or 3,000.
How is that possible?
Just by the nozzleman going around. He makes mistakes in a certain area, doesn't mean he makes a mistake uniformly around the pool. I don't want the viewership of this podcast to say, okay, if I have 6,000 PSI, it's okay everywhere. That's not the case. What we have found with expert witness testimony and construction defect, if the majority of the cores show bad concrete installation, the pool's not going to perform. If the majorities perform, we have good values except for these two areas, well, fix those two areas and move on. So you have to make an educated analysis when you do something like this.
The more you say, the more I realize, oh, that opens up another can of worms. Let me do some rapid fire definitions that you can explain these, because we do get these questions. We have a new help center, ask.orendatech.com, and people ask specific questions. But I'm going to go through and we're just going to ask you to define what these things are real quickly. You ready, Bill?
I'll do my best.
What is rebound?
Non-cementitious stone aggregate that bounces off the receiving surface.
The receiving surface. So explain that. You're shooting, so verb. Shotcrete is a verb.
You're shooting onto something, the aggregate that bounces off, it ricochets off, that's your rebound. It's non-cementitious and it should be thrown out.
It should be thrown out, not put back into the mix.
No.
So there's going to be waste involved when you're shooting a wall.
Should always have waste. At the beginning of the shot, you get 15% waste, and it probably goes down by the end of the day 5% because you have a flexible plastic receiving surface that accepts a rebound.
Now that term is closely associated with weepers.
Yes.
What are weepers?
Well, weepers or effervescence or the calcium leaching out, it's an indication of porosity and permeability, or holes or voids. So when they throw the rebound into the steps, you get weepers out of the steps. It's not tightly compacted concrete matrix. It's a bunch of rocks creating voids where the water finds path of least resistance and weeps out to the surface of the shell.
And takes minerals with it. That would be the efflorescence, or as you say, effervescence. I think those words are used interchangeably.
Is there common places for weepers, or is it just pretty much anywhere?
It's where they shovel the rebound into the steps, or they use filler. Okay, or on top of staging, shooting the bond beam, they can't get it right, so they shovel it up and they hand place it. So non-shooting areas and shoveling garbage so they don't want to throw it out. All your liquid flowable components exit in the path of least resistance. That's where it happens, in your porosity and permeability areas.
Okay. What's the difference between Gunnite and Shotcrete?
Gunnite is a term used to describe the dry shot method, and Shotcrete is the overall terminology for both dry and wet. In the old days, it referred to wet mix. So Gunnite and Shotcrete are an action or a verb, and they describe the Shotcrete method, which is spraying concrete at a high velocity.
Okay. What is a cold joint?
Cold joint is a lack of commingling between two different concrete applications.
What does that mean? Give me an example.
You pour a sidewalk and stop at the end of the day, and you got another mile of sidewalk. You start again, and you butt it up against a sidewalk that's already hardened. That is a lack of commingling. There is no such thing as a cold joint in Shotcrete because the receiving surface is on a three-dimensional bond plane. It's roughened up, and then you shoot at a high velocity, and that paste gets forced into the pores of that previous day receiving surface, and they make a mechanical locking bond, and therefore there's no cold joint. Shotcrete is monolithic. Means I can shoot a pool today, stop halfway through, come back next year or in 10 years, start again where I left off as long as I prep it properly, and that is not a cold joint, and it'll be monolithic.
I mean, one piece, like you're never going to tell them apart?
I mean, I do subway shooting and subway construction and consulting, and we've added on the Grand Central Station since 1930s, so monolithic.
Right on. Okay. So let's talk about cracks. What is Craze cracking?
Shrinkage. So you have a transition of the concrete going from a flowable state to a hardened state. When it transfers into a hardened state, the concrete shrinks. All concrete cracks, whether it's the volume of the concrete shrinks into that hardened state, or you have a performance or an application crack which shows that you're on fill ground and the pool settles. You don't have enough coverage over your steel and you have a crack over the steel. You have autogenuous cracking, you have shrinkage cracking, you have plastic shrinkage cracking, you have volume cracking, there's a lot of different structural cracking, settlement cracking, differential settlement cracking.
This is kind of like Forrest Gump. Shrimp scampi, shrimp stew, shrimp salad.
Shrimp gumbo.
Shrimp gumbo. Okay, I get the idea. What can you do to minimize these types of cracks?
So water cement ratio is critical, and not weakening the mix in a hot day, and also enough steel. Steel in the steps, the benches, the spa dam wall, the spa bench. So concrete gets very, very hot when it hydrates. When water hits the Portland particle and it grows these calcium silicates, it's a heat generation chemical process. So when it gets very, very hot, it dries up the water within the matrix, which doesn't let it get to full strength. But in steps and benches, it gets the hottest. So you need the most steel in these big volume areas of concrete. Pool guys get that wrong. They put the least amount of steel in those areas, and that's why you get most of the cracking in the large volume areas, because steel is not there helping mitigate some of the hydration process, making the concrete shrink and crack. You need the steel to help do that.
Steel meaning rebar, right?
Rebar.
You use some good terms there that might need some clarification. You say hydrate, and when you're hydrating a surface or whatever cement may be, what's the difference between hydrating and curing?
The hydration process is the process in which Portland cement comes in contact with water. You have a hydration chemical process, a heat generating process, and a bonding calcium silicate growing connection. That's the hydration process.
And that happens on the truck.
Well, it can. It's supposed to start in the truck, but really it's supposed to happen in the pool, because if it starts in the truck, that truck driver's in a lot of trouble because he's going to lose it if he doesn't get that concrete out of there.
No, what I mean is like Shotcrete, when we say it's wet mix, the water's introduced there and then it's pumped in and nozzled into the pool.
That's right.
Gunnite is dry and that's where it's introduced to water, so that's where the hydration would occur for Gunnite as opposed to wet mix.
The water addition happens at the nozzle for dry and it happens in the truck for wet. The hydration and the heat generation and the strength gain process, you want to make that happen in the pool after the water's added.
And so the water is actually going to be leaving that process, which is what reduces the volume and causes the shrinkage cracks. Am I understanding?
When it
that correctly?
evaporates, when it gets hot, yeah. So you want to control that as much as you can so you don't get as much shrinkage.
Now let's talk curing, the second half of Jared's question.
Curing is the aid in strength gain. It's a temperature control on the surface of the concrete. So you place all this concrete and you put your hand against the concrete and wow, that's really hot. It's getting warm. Well, it's hydrating. It's going through that hydration strength gain process. How do I maintain that hydration process and not let it get out of control and get so hot that the water in that cement matrix evaporates before it has a chance to hydrate more Portland particles and get more strength? Okay, and that's where we put water on the shell and we keep the shell cool. We keep the temperature of the surface of the concrete down, which in turn keeps the temperature of the internal concrete manageable so the water stays as water, not turn into gas. Strength gain happens when the Portland particles microscopically become hydrated with water. It doesn't happen instantaneously. It takes years to get all the Portland particles hydrated with water and get ultimate strength gain. So Hoover Dam, still getting stronger today. All the Portland particles have not been hydrated within that concrete matrix and that concrete thickness microscopically. Same with pools. Concrete gets stronger over time. We work on pools that were poured in the 30s that have 10,000 psi still to this day. So concrete gets stronger over time. And how does it get stronger? The Portland particle gets hydrated with water and starts a hydration strength gaining process. And it takes a long, long time to get total strength.
I don't know about you, Jared, but that's something new. I didn't know that concrete got so hot. My thought for curing was it drinks water. It needs to drink water. I had no idea it had anything to do with temperature. I thought it needs more water because the original water is getting used up and converting into calcium hydroxide and all these other things, and therefore you need more water to convert the rest of the cement in the mix. I didn't realize it was about temperature.
If you have water penetrating your concrete to do hydration in the middle of the concrete wall, your concrete wall is no good because it's not watertight. Your pool's got to be watertight on the surface with a good solid matrix. The curing is just to keep the mixed water that came from the truck or came from the nozzle in there and not evaporating, turning to a gas. That's what you do for cure, to allow the other water in the mix to hydrate and gain strength.
So that makes sense to me, just as far as, when I see what we were talking about crazing earlier and check cracks.
Yep.
Usually that happens on the tanning ledges and the benches that are flat surfaced, exposed to the sun. And that's because they just get too hot because there's not enough water to keep them hydrated, or when the curing process, they're not controlling the heat enough and they just shrink.
That's right, Jared. Controlling the heat and curing would eliminate a lot of these shrinkage cracks on the pool shells that the plaster goes against. If everybody put a soaker hose and cured the shell or had some type of moisture content to control the heat and control the temperature gain, you'd have a lot less shrinkage cracks out there.
You were talking earlier about the PSI of the concrete and the integrity and the strength, and how if you add more water, it reduces the PSI.
Yep.
Once the gunite or cement is applied to the shell and it's set, right? You're setting it.
Concrete.
Is water getting into that after, when you start the curing process? Because a lot of people will have you hose it down, put something in there to keep it wet,
like
we're talking
sprinklers,
about.
right?
Yeah. So that's not degrading the PSI or the integrity of the shell, correct?
It's doing the opposite. It's helping it by keeping the shell cool.
Makes sense. I mean, I see these soaker hoses.
If you're in a hot, non-moisture climate, I would cure it as long as you can before you put the tile and the coping and everything else on there. I mean, we get this all the time. I get people who hire us and say, well, the pool contractor says it self-cures. I got a client who says the pool contractors in Florida say, well, we don't need to cure. There's so much moisture around. And I'm like, well, no, Your Honor, that's not true.
What about groundwater? Can
Groundwater is okay if you can mitigate it and stop the hydrostatic pressure under the initial strength gain process. If you can keep it pumped away, and then once the concrete's hard and went through your curing process, you let groundwater around the shell, that's actually good for it.
Okay. Let's wrap this episode up here. This is great information. And I know most people listening to this are in the service trade or they're homeowners. I know there are some pool builders that will find this specifically valuable, but to those of you who are servicing pools, if you have a structural issue, chemistry didn't cause that. That's what we have Bill on here for, because we often get calls, and efflorescence is the one I'm going to pick on, where there's like calcium scale on the outside wall of a raised spa, nowhere near the spillway. And we keep saying like, hey, that's moisture that came through the spa, took minerals with it, and then it comes through the grout between the stone or the bricks, and then it drips down. We actually see that quite a bit, and people ask if our SC1000 can clean it up. I said, unfortunately, no. That spa wasn't properly built. It wasn't waterproof. Now, we say it wasn't waterproof. That's a shortcut for us because, again, we're not pool builders, but we use it as an insurance policy. So I've been recommending to people, if you have anything raised, specifically a spa or a vanishing edge wall, why not waterproof it? And you're saying it's because it's worse adhesion between the concrete and the plaster. Am I understanding you correct?
If you don't have a watertight shell, we'll do a tank test. We do a vanishing edge. We'll fill it up full of water, and we'll make sure we don't have any water coming through the concrete to the other side. If I can prove that, I don't waterproof it. If I have an issue and I had a couple of staging spikes that went through the edge, and all of a sudden I got a couple of little bleeders through my vanishing edge, I'll waterproof it. Absolutely. But I'll go back to the least amount of materials from bare concrete to bare plaster, the longer that plaster is going to stick to that pool. There's no question about that.
Minimalism, I kind of like that. We want the least amount of stuff in water. We want the purest water possible. And it sounds like the best way to prep a Shotcrete pool shell for plaster is the least possible, right? I mean, how do you prep for it so that you get the most adhesion between the plaster and the Shotcrete shell?
How do we prep for it? We scrape and power wash.
Okay, so you're putting more water on right before you plaster, or what?
No, the day before we'll scrape the concrete, and then we'll power wash the shell and clean the concrete and open up the pores of the concrete so the plaster guy can squeeze his plaster into that three-dimensional bond plane and have a successful application.
Right on. Right on. Well, this has been good. I got a lot of my questions answered. Jared, any questions you have for Bill while we have him?
A lot of times I get questions with homeowners that'll call and say, hey, I'm looking at my Gunnite shell or my cement shell, and there's cracks or there's calcium leaching down or it's ugly. So what can you tell homeowners specifically when they have those concerns? What is your recommendation?
Send me pictures. Let me see exactly where your cracks are, exactly what's going on. But I would tell the client, shrinkage is going to happen, concrete is going to crack. But if you're getting staining and porosity and fluid through these cracks and it's in its concrete shell state, there's an issue, because that's going to affect the plaster application. And if you got water going through the ground, through your shell, into the pool, it's not watertight. The goal of Shotcrete construction, wet or dry, is a watertight shell before surface application. The American Concrete Institute is writing a specification code for pool concrete, and that's going to be one of the mainstays. Is whoever's shooting this shell is shooting it so the shell is watertight to the nearest days of evaporation.
Let's assume it's not watertight and there's just a little spot that's letting moisture through and you can see it, right? How do you remedy that?
Well, you'd have to waterproof it.
Okay. So the waterproofing comes into play in this equation in certain instances.
This is why waterproofing is in existence in the pool industry. Bad pool construction.
Well, hold on. We've seen pictures where it's Shotcrete shells with so much calcium coming through, so much efflorescence and weepers. Are you saying you just waterproof on top of that and call it good?
No, you clean it off, you power wash, and you get it off, and you find out what's going on, and you prep the shell, and you follow the rules of the damp proofer, and you apply their product to the best of your ability in the directions to hopefully hold water that it doesn't seep through the plaster.
So you got to clean it up and prep it.
Well, it sounds like a judgment call. Like I remember watching Vegas Vacation, the old Chevy Chase National Lampoons, and they go to Hoover Dam, and they're going on the dam tour, and there's a little leak, and he puts a piece of gum on it and starts filling up the piece of gum. So he puts his finger on it, then a new leak sprouts 5 feet away from him. So he reaches over, and it's a comedy movie, of course. But that's what I'm thinking of. Like if the moisture's coming through, it's going to find another way through. And it's kind of like putting a Band-Aid on it, it sounds like, because you didn't make it watertight. So here's my question, Bill. What's the difference between watertight and waterproof?
There's no such thing as waterproof under infinite pressure over infinite time. That term doesn't technically exist. Watertightness is the ability to hold moisture to that day's evaporation plus or minus.
I think we could wrap this one because we're going to talk about plaster in the next one. Thank you for being on here. Just so you know, to the audience, we've talked about in the last several episodes as part of our housekeeping, Bill is teaching that main class that we are going to be doing with Watershapes. That class number at the International Show, November 12th and 13th in Las Vegas. This is for the trade, not homeowners.
This is the year 2022, just FYI.
That's right. For those of you listening 10 years from now, this actually was a class that happened November 12th and 13th in 2022. Thank you, Jared. Smart ass. It's going to be in Las Vegas. It is WU for Watershapes University, C3611, Essential Plaster Workshop. There are only 60 seats available. Bill will be teaching this material and more on Shotcrete, and then John Temple will be talking about plaster and exposure, and I will be talking about what happens once the pool is being filled and once it's full. So we hope to see you there. If you are available, just go ahead and sign up for it online. And apart from that, is there anything you want to add, Bill?
No.
The
Jared?
only thing I'll add is it sounds to me after that dissertation on the class and kind of what you're covering, John Temple's covering, and what Bill's covering, we're not perfect. Nobody is. The only thing we can do is educate ourselves, become as much of an expert as you possibly can, and try to do the right thing the right way. And hopefully these problems just don't occur. But at the end of the day, we all know things happen, but we got to make sure we do our homework. So that's what kind of we're doing this for is, hey, I don't know anything about concrete.
Do your homework. That's right. So all the standards that we go by, PSI and all this stuff, does not come from the pool industry. Concrete strength and all this stuff we talked about from the American Concrete Institute, American Shotcrete Association, and they are not pool specific. So that's a great point, Jared.
Awesome.
Yep. Fair enough. Well, this has been episode 80 of the Rule Your Pool podcast. In the next one, 81, we're going to talk specifically about plaster, which is also cement, but it's going to go on top of that concrete. Bill, thank you so much for your time. Jared, thanks for finally showing up. I know you didn't read the show notes based on your questions, but
hey, Neither did Bill. We're in this.
On
We're in
brand.
this together.
Got it right in
I
front
was
of
going
me.
to say,
Smart guy.
right in front of you, just weren't looking at them. That's great. No, you guys are, you're killing me. You're killing me. Anyway, thanks so much for your time, everyone.
Thank you.
Thanks.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.